Now this example over here couldn't be finished in the last video. I did A and C, so I know I worked a little bit out of order, but that's because A and C were so similar. And now I'm going to work on B. B is when you've got a logarithm equation. So A and C were exponential equations, and you had to take the log of both sides to get the variables out of the exponent. For B, it's a logarithmic equation. So we don't need to take the log of both sides. We already have a logarithm in there. What we need to do is get rid of the logarithm. So it's 4 ln of 3x plus 2 equals 71. Now, what we're going to do is we're going to get the logarithm part by itself. So the first thing I'm doing, oops, I should probably clarify. The first thing I'm doing is subtracting 2 from both sides. Okay, so that gets me 69 on the right. These are going to disappear, right, because 2 take away 2 is 0, so that's gone. Now, some students want to put the 4 up, but that would not be a wise move because you don't know how to solve a quartic equation like that. So what you want to do is you want to divide by 4. You want to get that logarithm as plain as can be. So you're going to have, let's see, 4 divided by 4. And the reason you can do that is because division, 4 divided by 4, makes 1, right? So you're left with the 1 times the ln of 3x, which we're too lazy to write the 1, but it's there, equals 69 over 4. 69 over 4 would be, hold on, 69 divided by 4, 17.25. Okay, so we have 17.25. All right, now we want to rewrite this because you want to get x out of here. And students make the mistake of thinking that parentheses means times. It doesn't mean times, it means logarithm. You can't just divide, that's not multiplication. You need the inverse of logarithm, which is exponential, not logarithm, right? And not division for sure. So don't try to divide by 3. That would be bad, 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 bad. What you can do, though, is rewrite it using the definition. So e to the 17.25 is equal to 3x. Now there's no more logarithm. So I guess I'll just make a note. So note, use exponential form, right? Okay, so e to the 17.25 is something to find with a calculator. Second e, right there above your ln button, to the 17.2, oops, I missed my point, 0.25. There, it's that big hunk of number. So e to the, oops, see, I'm going to rewrite this, 3x equals, there we go. And then what was that number again? Because that was huge, 3101. 31015573.27. Okay, and then to get x by itself, we're just going to divide both sides by 3. Oops. There we go. I'm trying to make the 3 disappear. Okay, so we have x is, oh, well, this was squiggly equals, to be fair. Once we started rounding, your calculator is rounding some of that business. So that's all right. Then we divide it by 3. So let me grab my calculator. Divide by 3, enter. So you get 10338524.42. It's huge, but you know, hey. Now, all of this in this entire page is review. We've done problems like this before. We just didn't do it with ln. We did them with log back in section 5.2 and 5.3 and 5.4. So this is the first time we've done it with ln, but other than that, it's exactly the same stuff. Oh, we did them in 5.5 as well. Speaking of 5.5, let's use this property. So the subtraction property is a property we first learned about in 5.5. So let's do it. We are going to make subtraction turn into division. So it's going to be, let me write it out, 4 ln r to the third minus 2 ln 7r. Okay, so now the power property says that you can make this r to the third to the fourth minus ln 7r to the 2. Now you may be thinking, wait a second, Alana, didn't you just say don't bother putting the power up? Yeah, that was for an equation. See how there's an equal sign in this problem? That's a different story because you're trying to get the x by itself, so you want to get rid of the 4. You don't want to make a power out of it that makes things harder for yourself. You just want to divide it away like we did down here and made 69 over 4. But in this problem that we're doing right now, there is no equal sign. You're not solving this. You're trying to simplify. So you can't divide by 4 because there's nothing to divide it into. There's no equals 22 over here. Right? If there was, that would be a different story. All right, so then we've got ln. Now remember your power rules from 4.1. This is to the 12 because you multiply, minus the ln, and then this is 7 squared. Oops, I guess I should do this. 7 squared r squared. And if you will, I'm going to do this 3 times 4. That way you guys can see it. So this is ln of r to the 12, like I just said, minus the ln of 49r squared. Now you still have to mush them together. So this right here, going this step, was using the power property. And then these next 2 steps are just using simplification. That's all you're doing down here. Okay, both of these steps. And now we're going to use the quotient property. So you're going to say this is the ln of r to the 12 over 49r squared. And we're using the, oopsie, we're using the quotient property on that. All right, so this is the ln of r to the 10 over 49. Because remember, if there's 12 r's on top, 2 on bottom, they cancel and leave you 2 left or 10 left over on the top. Or you think you could subtract 12, take away 2 is 10. And the bigger one's on top, so the 10 stays on top. All right, we're done with that one. Oh, I should really have equal signs through all this. My fault. Just to show that I'm following my steps. You know, every single step was equal to the next step. All right, so now let's do part B. And actually, if you're okay with this, I'm going to add to this a little bit. Just, you know, for the heck of it. I'm going to add the ln of x on the back, minus the ln of x. Just because I want to make this question just a little bit more tricky, right? So if I do that, it's not going to, you know, change your world or anything. Let's see what it does. So we've got 3 ln of x to the 4th minus or plus 2 ln 3x to the 3rd. And I added in minus ln of x. I know that that's going to throw you, but it's good for you because it makes the problem a little bit different. Okay, so now the first thing we're going to do is use the power property to move the 3 and the 2 up. So make it ln of x to the 4th to the 3rd plus ln of 3x to the 3rd to the 2, like that. And I added in this minus ln of x business at the back. All right, so again, we're using the power property on this part. All right, then that's equal to the ln of x to the 4 times 3 plus ln of 3 to the 2, x to the 3 times 2. And then I just tacked on that minus ln of x in the back because I'm mean like that. Okay, so we're just doing a little bit of simplifying here. And then we got to keep simplifying because this is no good to us with the 4 times 3. So we went ln of x to the 12 plus ln of 9x to the 6 minus ln x. All right, equals. Now we're going to get beyond simplify. We're going to use the product and the quotient properties. So I'm going to make ln of, I'm going to make a big fraction. Now everything that's positive goes in the numerator. So you say x to the 12 times 9 times 9x to the 6 over x. Right, just one plain x, he goes in the bottom. And if he didn't do make that addition that I just did, then this numerator would be all you have. That's okay. Right, so it would be equal to ln of, okay, on the top you have 9x to the, you got to add those, 12 and 6. 12 plus 6 over x on the bottom. So this is equal to ln of 9x to the 18 over x. Now, if you didn't do my addition, 9x to the 18 would be all you have. But if you did what I did and added in just a little bit something, something, then that makes it 9x to the 17 because there's 18 on top and I threw in that one more that went to the bottom. All right, we're all done with that. We have a few minutes left, so let's see if we can get through the next one. All right, so we're going to solve giving 3 decimal places. So let's see here. So I have 5 ln of 2p minus 2 ln of p squared equals 3. So the first thing I'm going to do is use the power property and get these 2p to the 5th minus ln of p squared. Now you may be thinking, well, Lana, you just said not to do that on the other page. Yeah, that's true. Back on this one right here, I said not to bother. Remember, I just said, oh, here, hold on. Oh, just divide by 4. But that's because there's only one logarithm on this one. See that? When there's only one logarithm, that's actually quite a bit easier. When there's 2 logarithms, you got to really kind of simplify it down first, and that's what we're doing. All right, so this is the ln of 2 to the 5th, p to the 5th, minus the ln, the natural log of p to the 2 times 2 equals 3. So this is the natural log of 32p to the 5th minus the natural log of, oopsie, p to the 4th. Okay, so I use the power property right here. And then I'm simplifying for the next 2 steps. Okay, simplify, simplify. Now I'm here, I'm going to use the quotient rule and make one logarithm out of it because when you have an equation with a logarithm, you want to rewrite. But you can't rewrite unless you only have one logarithm, and we have 2. So you've got to make it so that there's only one logarithm. So I'm going to do 32p to the 5th over p to the 4th equals 3. All right, now I'm going to simplify again. So this was the quotient property I'm using right here, right, to mush them together and make one logarithm. All right, now I'm going to write ln of, that's 32p equals 3 because there's 5 p's on the top, 4 p's on the bottom. They'll cancel and leave you one left over. So now I'm going to rewrite. So this was simplify again. Now I'm going to rewrite e to the 3 equals 32p. Right? Because e is my base. I don't see a number there, but it's ln. ln is base e. So I write e to the 3 equals 32p. Now I want to solve this for p, so I'm going to divide by 32 to both sides. And then p is whatever e to the 3 over 32 is, right? So that's technically an exact answer, but I'll get a decimal for it. So clear. E to the 3, enter. Divide by 32, enter. Gives me about 0.628. 0.628. And there's our final result.